Also need to finish with, in cost estimation, this concept called learning curve effect. And the learning curve effect just comes from the fact that if you're trying to produce something, you might want to tell us the total cost of making something. So maybe you want to make 10 units. Total costs are always materials, labor, and overheads. So if 1 unit maybe materials you are buying at 10, the 10 units times 10 will be 100 shillings. Laborers, if you pay for every unit 30 shillings, if they make 10 units, then you might want to multiply and get the 300 overheads. If it is 200, you might want to come with the 200 so that you add and show that the total cost of what you are making is 600. But now, learning curve comes and says when you are estimating this cost, it might not be prudent just to take maybe something like labor. If 1 unit you are spending 30 shillings, 10 units you should not just multiply by 10, because as laborers are producing, the effect basically states that when you begin something for the first time, you take a lot of time to produce that 1 unit. But as you make more and more units, then you become confident, you become more experienced, and therefore you will find that you are taking less and less time to produce whatever number of units that you are producing. So this reduction in time as you make more and more units is what we are calling the learning curve effect. So you might always want to factor how much time will reduce as you are making more and more, so that you capture it. So that what we are basically saying is the effect of learning curve basically states that if you were to maybe capture some cumulative units which you are giving your laborers to produce, and then you try to observe the total time it takes them to make those cumulative units, and maybe you might even be interested in knowing, as they are making more and more, what is the average time per unit as they proceed with the production. So the effect states that if maybe the laborers, you tell them to make the first unit, cumulative units is all of them, so by the time they have made the 1 unit, you might find that they have taken 100 hours to make that 1 unit. So it means the average time per unit is, since it is the only 100 divided by 1, the average time is still 100 hours. But now tell them to make 2 units cumulatively. That means the first and the second. So by the time they have made the first and the second unit, so cumulative 2 units, the first one and the second. So because they took 100 hours in the first one, this effect states that 2 units will not take 200. They might shock you, instead of taking 200 hours, because 100 times 2 should be 200, you might find that now they take 100, your laborers take 180 hours to make the first 2 units. And therefore, if you come to get the average now time per unit, 100 by 80 divided by 2, those are 90 hours. So you can see something that has happened, that 1 unit before was taking 100 hours, but now the moment they have reached 2, the average time now has reduced to 90. Whatever has just happened here is what we are calling the learning curve effect, because they are learning, they are improving as they are making more. So the effects also goes further and says, by the time they have made 4 units, that is the first, second, third, and fourth, cumulatively 4 units, you might expect that they will take 400 hours, but they might shock you. Instead of 400 hours, you could again get a shock and find that instead of 400 hours, these people might take 324 hours to make the first 4 units. So that by the time you're dividing 324 divided by 4, the average time for each of those 4 units now reduces again to 81 hours. So again, something is happening. So this reduction in time per unit as they make more and more is what we are calling the learning curve effect. And that rate, so the learning curve effect concept basically states that every time laborers double the previous units, like now they were making 1, by the time they have doubled to make 2, by the time they have doubled to make 4, the average time per unit will reduce by a constant rate, which is what we are calling, you must always call the learning or improvement rate. It is the main thing that we will always be interested in. And how do you get it? It is just the reduction in time. From 100, now you are getting 90. So 90 from 100, you will be saying, or even 81 from 90, you will be getting maybe a 90%, like in my example, you will be talking of a learning or improvement rate of 90%, meaning the laborers are cutting down the average time per unit by 90% every time they have doubled the previous unit. So once we have this in mind, it now means when you are preparing a cost statement like this, labor hours will require time. You should not always just say that the first unit took 100, so 4 units will take 400. That one will be wrong. So because you will need to multiply the hours they have taken by your rate to find the labor cost. So when you are forecasting for how much time it will take to make more and more units, you will need to appreciate that something like this will be happening. 1 unit was 100, but 2 units will not be 200. 4 units will not be 400. So if you can get the exact time, you will be able to estimate the labor cost and any other associated cost more realistically, so that you are able to generate a more realistic and accurate cost estimate for whatever production you are taking place. So this is what we are calling the learning or improvement rate, that every time you double, time will be benefiting. So if you wanted even now to make 100 units, you need to be able to expand this table until you get to the 100 that you are doing. But then that might be very cumbersome, because the idea now is if now I was to make the first 8, this will just reduce by 90%. I get what it is, and then I can multiply together total time. But because now we are saying these total times are needed, instead of maybe working with a table, it might be more convenient to work with a formula. Okay, so learning formulas exist, which can be able to give us these times that we are looking for. Things like this average time and the total time can always be generated more conveniently using a formula, so that anytime somebody wants you to tell them, if I make 100 units, how much time will it take? Or what will be the average time per unit for me as I make more and more? So formulas exist which can give us all these times, the average times and total times. And the formula that you must always be able to use, the learning curve formula, is always y. You can even say maybe yx will always be ax to the power of b. Okay, that is a very important formula which can always give you all these things that we are looking for, where now yx will be this column. Anytime you are looking for the average time per unit for cumulative number of units, x, that is what yx will stand for. It is this column that we are having here. Okay, so this formula of ours can give us that. Now the only condition is you must always be given in the question the value of a and ways of getting b. A must always be provided. A will always stand for the time. This one should be known for the first unit, or even units if you are combining them into more than one unit. So the time to make the first batch or the first unit should always be known. This one here, like now, if you told us the first unit was 100, that one will be a constant always. If it is given, you will just put there. Okay, and b is a very important constant. We call it the learning or improvement constant. It's just a learning constant, and it will be given by log r divided by log 2. It will be given by log r divided by log 2. So if you can be able to find the improvement rate, so you should be knowing the rate at which the employees are improving. That one will be provided. Like now, if you're told employees are improving at a 90% rate, that will be what you will put there as log of 0.9 divided by log of 2. So that, for example, now in our example here, if we wanted to find maybe this 90, we can get it very easily. Let's see if the formula works. We will just come and say, in our example here, I will just come and say that b, now that we have said it is log r divided by log 2, if the question had told us that these people are improving at a 90% rate, I will get b by simply saying it will be log of 0.9 divided by, it's a constant. It will be now that they are improving at a 90% rate, you'll always get it. So you just go to your calc and say there's a button for log, so you just say log 0.9 divided by log 2, and it will always be a negative. You will get something like a negative 0.152. That will be your constant, which you will be using to get any combined number of units. So after that, if A is given, A we were told is 100, the time the laborers took to make the first unit, if it's 100, just put it there like that, so that now any question can be answered, like in this case. So the questions which somebody now might want from you, let's set some question to see. We already have some we used to the table, which we can also get using the formula. So suppose somebody in this case, suppose I was to get this 90, which was I would just say I am looking for y2. Okay, remember the formula is here. Let me maybe put the formula. We said yx will always be equals to ax to the power of b. So if somebody said y2, what that means is looking for the average time per unit for 2 units cumulatively. This time that now after they have made 2, what time will they have taken? We want to see whether the formula works. So we'll just go for A. A was 100. The first unit, these employees took 100 hours. So you come and put your 100 there. And X is 2. We want them to make 2 units. So you multiply by 2, raised to the power of this value, which is minus 0.152. So if you just raise it to minus 0.152, this should exactly be the 90 that we got. So we can come and say 2, I'm just doing that mathematics there using my calc. 100 times 2, that one anybody can do. So 2 raised to that value of hours times 100, you get exactly 90. So this one means the laborers will have taken 90 hours per unit, but that is average. So anytime, even if you wanted y10, if you wanted to find the average time to make 10 units, then you just say y10 there, put your 10 there, raised to the power of this constant, you will get that average time. But now, for practical purposes, nobody is really interested in average times. For purposes of working, this side of getting the total time for all our units is more critical, because you will be needing to know after they have made 10 units, how much time have they taken, so that you can plan as a management accountant to pay them wages, or even to plan for how to schedule the laborers, whether there is need for overtime and so on. So it is more important to get total time. So how do we get total time? Remember, we have said the formula for average time is that one. What is more important, therefore, this is the most important thing. The most important formula is TX. That means, what is the time to, this TX to stand for total time. How do we get the formula for total time? But it is simple, because we have already said y is equals to ax to the power of b for average time. So, but what is an average? An average is total time divided by the units. In short, once you get 100, you multiply by 1, you get the total time. If the average time for each unit after 2 units are made is 90, to get 180, kama kila moja yao ni 90, just multiply by 2 times 180. So in short, if you have an average, multiply by the units, you get total time. If you have an average, multiply by the 2 units, you get 180. If you have 81, times 4 is 324. In short, total time must be the average time for each of those units times all of them. So we can come here and simply say, now that we know the formula for average time is this, so I can just take that average time for those units, multiply by x again. If you multiply this by x again, those are the units, we will be getting total time. Average time times all the units. In short, a better formula, or a more realistic formula for purposes of working our things, will be tx is x raised to the power of b times x raised to the power of 1. So because the base is the same, you just add the powers. So inakuja inakuwa b plus 1. This is a more important formula, which we can always use to get total time for any cumulative number of units. So we are saying Tx will always stand for cumulative time for x units. X could be anything. So if in our example, suppose I wanted to find this 324, I would just come and say, I am looking for the total time to make how many units? 4 units. So Tx is T4 in that case, and A is still 100 times the 4 units that I want to make raised to the power of B. B, we had already found this plus 1. So this plus 1 minus 0.152 plus 1 looks like minus 0.848. So if we solve this, we should be able to get exactly the 324 that we are getting for these employees that are improving at a 90% rate. So we simply come and say, 4 raised to the power 4 raised to the power of 0.848 times 100, you see we are getting 324.00, which is exactly this. So this is 324 hours. So we can always work with the formula. So in short, always be able to work with these formulas that we are talking about. If you even wanted to find, like now, questions can arise. Somebody could ask you other things that find time for maybe fast 8 units. That is a question you might want. Somebody might ask you, find time for the 8th unit. Another person might ask you, find time for fast 32 units. Those are questions which somebody might want, and we will do them after this. Then somebody might ask you, find time for last 16 units in a group of 32 units. So if such questions arose, you should be able to work with this formula, and you simply solve them, which we will do in the second part of the video. Thank you.